Hello everyone, today we're going to talk about electrochemistry for Unit 9 for AP Chem. So we're going to talk about batteries, we're going to talk about lemons and how to make batteries with different objects. It's a very interesting unit and hopefully you enjoy this. So let's talk about what electrochemistry kind of comes down to. So electrochemistry is a very interesting topic because what it does is that it covers reactions that can generate electricity that you could use for various purposes like batteries and cars and rusting and all that. And so let's talk about how that actually works. So we usually have what we call these redox reactions or oxidation and reduction reactions. And generally we have two things. We're going to define what an oxidation reaction is. So an oxidation reaction is generally going to be a loss of electrons. So whenever you have a reaction that is just bleeding out electrons, we're going to call it oxidation. When something is gaining electrons, we're going to call it reduction. And so we call this, in short, a redox reaction. So to bring this occur, we usually have what we call a redox reaction happening. And this generally is a great example of something to remember, kind of like what we'll call an oil rig. So an oil rig is basically means oxidation is a loss and reduction is a gain. So we're going to use this kind of mnemonic to think about that. Or you can think of a lion. A lion is grr. A lion starts to grr or usually roar, and we're to call that as losing electrons is oxidation or gaining electrons reduction. So I challenge you to come up with your own mnemonic that could best represent a redox reaction. So let's talk about redox reactions in terms of these agents. So generally we call them as an oxidant. You probably won't see it too much as an oxidizing agent, but we'll call it as an oxidant. It's what's being reduced or has a component that's being reduced. So it's actually the opposite. Okay, and this term generally refers to something that has that ability to pick up electrons. We usually call it a reductant or a reducing agent, something that's oxidized or has a component that's being oxidized, not losing its electrons. So let's give you an example of zinc plus 2 moles of an acid. In this case, it will be an aqueous solution. When you add an acid to a metal, you generally are going to form hydrogen gas and the zinc ion. In this example, you have 2 plus ions of aqueous solution. So this is a great example of something where we do have a redox reaction. So because this is an elemental, we're going to assign this a 0. This is going to have a 1 plus charge because hydrogen here is going to have a 1, 0, and zinc is going to have a 2 plus. And so now we have to identify what is the getting reduced and what's getting oxidized. So zinc, because it went from a 0, is being oxidized to a 2 because it lost 2 electrons to become a 2 plus. Well, hydrogen here became a 1 plus to a 0, which now is getting reduced. Notice it added an electron. And the example here is that the charge is going to go from a 1 plus to a 0. And the reason is because if you add a -1 to the hydrogen, it becomes a 0. Well, here, if you lost 2 electrons, in other words, it becomes a positive number. So this is going to be what we'll call the reducing agent, and that is called the oxidizer. So actually backwards, right? So just kind of keep that in mind. All right, so let's go ahead and identify the oxidant and the reductant. Now, in this example right here, we're going to take a look at what is being oxidized and what is being reduced. So again, just kind of don't get too confused with these two. Sometimes they're going to be the opposite. So aluminum, we're automatically going to put 3 plus because we already know from the rules for oxidation that it's going to be that. For manganese, we're going to use 7 plus because again, there's 2 here for the -8 for oxygen, and that's going to be a 1, so that gives you a -1. And it's going to be a +4 for the manganese, and oxygen is going to be a -2. So in this example, we're going to look at MnO4 as our oxidant. In other words, MnO4 is going from a 7 plus to a 4 plus, so it's actually picking up 3 electrons, but we're going to call it the oxidant. And the reductant is something that's generally going to be losing electrons. So aluminum is going to go to 3. We usually call it as what is being reduced or what's being oxidized. So just kind of, it's going to be the opposite. So pyrrolidine will usually speed up the rate, and permanganate ion is a very strong oxidizer. Okay, So let's talk about balancing and reduction reactions on how to conserve mass and conserve charge. So we're going to be using what we'll call a half reaction. A half reaction is basically you're going to separate the oxidation by itself or a reduction by itself. So let's think of a piece of wood as an example, or iron that has iron in it. And iron is going to rust in one half reaction. So we're going to take just iron itself, and we're going to lose 3 electrons, which is going to be 3 here, and Fe3+. We're going to call this an oxidation because it lost 3 electrons. And the reduction half reaction is when we're going to be picking up the electrons. So oxygen here is going to pick up 4 electrons to make 2 of these. Now, one thing I want to mention is the electrons have to be balanced. So you have 4 electrons and 4 electrons on the right. Okay, so let's talk about the half reactions for as an example. So here we have a reaction where we're going to have to write the half reactions for each of the following. And we're going to have tin and iron. So the first thing we're going to do is focus on tin. So tin is Sn2+ and 4+. So the question is, how do we get to that 4+? And it's really easy because we know that tin has a 2+ here. So obviously it had to have lost electrons. And iron here went from a 3+ to a 2+, so we know it had to gain. So this is actually our oxidation, and that is our reduction. So now, how many electrons? That was 2, because 2 plus 4 gives you that 2. 2 minus 4 gives 2. In this example here, we're going to have 2 electrons and 2. So we have to balance this out to make this work. Otherwise, it's not going to. Okay, so the sum of the 2 reactions should be the overall reaction. So we're going to take these 2, we're going to add them all together, and we're going to bring them down. We're going to cancel out the electrons, and we'll be using what's called the line notation. So line notation basically is a way to represent those out. So you can actually just write these up as a line with 2 brackets in the middle, and this would represent the anode. To the left of this would be the anode, and towards the right of this would be the cathode. So again, the anode, I usually refer this to as like the letter A, and the cathode. And we'll talk about that you always write down the oxidation first, the one that's losing the electrons, and the one that's gaining the electrons would be the one on the right. Okay. All right, so let's go ahead and balance half